Hey guys, this is a really short video in A2, and it's just a random thing that we're doing, and it's going to be, we're going to determine the derivatives of sinusoidal functions. We're just going to make observations right now. Okay, so check out the graph of y equals sine x. So we know that that graph starts at 0, and then it goes up, it reaches a max of like 1, and it goes back to 0, then down to -1. Just done that, and then back up to 0. So that's what sine x looks like. So I'm not even going to put any values on this graph. We're just making observations here, and we're just going to see what the derivatives equal just simply from looking at their graphs. Okay, so we know that the derivative, if we wanted to figure out the derivative of sine x, actually let's write it as this. So let's say we wanted to figure out the derivative of sine x. Basically, we're finding the slope at every point on the graph, right? So I know like at these max and mins, they have a slope of 0. So on the graph of my derivative, they're going to appear right on like y equals 0. Right? Because the graph is telling us the slope at every point, and I know the slope is 0. Okay, so they're going to appear there. I know that my biggest slopes, so if I like just look at tangent lines, like I'm going to get my biggest slopes here, here, and here. And then they're just going to start decreasing. But I do notice that in this segment, all of my slopes are positive. So I have my biggest one here, so I'm going to say that that's probably going to have a slope of 1 if I were to calculate it, which it will. And then they're just going to get like less and less steep, but they're staying in the positive range. So they have to be on the positive side of the y-axis. Okay, then what's happening is my slopes are going negative now. Negative, 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 negative. But you can see that they're like getting more steep in the middle area, right? And then they're getting like less steep down here. So if I were to graph that, I could show that this purple section would be up in the positive section, and then this blue section's all negative, so that's going to be all down here, and it's going to be like not too steep, and then it's going to get steepest, and then it's going to get less steep. So like remember this, like the derivative, the graph of the derivative shows you the slope at every point on your graph. So if you know that right here on sine x has a slope of -1, then that means that the slope of the derivative graph here will be at -1. Like the derivative y value will be at -1. Okay, so that, and then since like this whole blue segment of sine x is in the negative, is a negative slope, then I know that it has to be like in this section of the graph to show that how it's a negative y value, because it would be a negative slope. Okay, then you see that your slopes are getting positive again. So now we're back up in the positive range. So you can see from that graph, like this is the graph of y equals sine x, and the graph of the derivative is also going to be a sinusoidal function, and it's actually, if you recognize it, it is the graph of cosx. So it starts at 1 and then goes down and back up. So the derivative of sine x is cosx. So that's kind of neat. So that is something you'll want to know for the rest of your life. The derivative of sine x is cosx. Okay, pretty straightforward. Okay, now let's look at the graph of y equals cosx. So it starts at 1, then it goes down to 0, then it goes down to -1, then back up to 0, then back up to 1, and it just keeps going. So that's what cosx looks like. So if we want to figure out, okay, what's the graph of the derivative look like? Okay, so again, at all the maximum and minimum points, we know that those points have a slope of 0, so they're going to appear on the x-axis. Okay, so we got those figured out. Then we just got to go with, like, if the slope is positive, it's going to be on the, top part of the graph. And if the slope is negative, it's going to be down here. Okay, so right off the bat, I'm just going to do this in green. Ooh, I'll do fluorescent green. Right off the bat, it looks like we have negative slopes. See how it's going down to the right? So this whole segment's negative, which means the graph of our derivative, it's starting here, and it has to stay in the negative section all the way to here. So it's going to go like this. Okay, next, it looks like after we hit 0 here, now it's changing to a positive slope. So it's positive, 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 and back to 0. So now I know the next segment of my graph has to stay in the positive y values and then go back to 0. Now, I'm not going into great detail about like actually finding the slope of the tangent. So this is just, we're just doing this like based on what we see. But what I'm seeing is the derivative of cosx. What does that look like to you? So it doesn't look like sine x. That's too bad. But it does look like the mirror image of sine x. So sine x usually starts at 0, 0, and then usually goes up to 1, back to 0, negative 1, and 0. So the red graph is actually like a reflection of the sine x graph, a reflection over the x-axis. So it turns out the derivative of cosx is actually negative sine x. Another thing you have to remember forever. Okay, so derivative of sine x is cosx, derivative of cosx is negative sine x. All right, so I don't know why it comes up in A2. It seems super weird because that's literally all you have to know. That the derivative of sine x is cosx and the derivative of cosx is negative sine x. And we are going to do more on this after we learn a whole bunch of other derivatives.